Today, every computer scientist, every mathematician, and every engineer who works with data, everyone whose life revolves around computers, relies on an idea that was once considered too dangerous even to teach. That idea was this: infinity is not a single thing. In fact, some infinities are larger than others. The man who made this discovery was not welcomed with praise. Instead, he became the target of relentless intellectual, professional, and personal attacks from the very scientific community to which he belonged. His own mentor gradually became his greatest enemy. Religious authorities began questioning both his sanity and his faith. And little by little, the mind that uncovered one of mathematics' deepest truths began to collapse beneath the weight of that very truth. This is the story of Georg Cantor, the man who proved that infinities can have different sizes and paid for that discovery with his sanity. During the 1870s, mathematics had well-established boundaries that few dared to question. Everyone accepted that numbers could continue forever. Yet infinity itself was believed to be a single, indivisible concept. Infinity was simply infinity. There was nothing to measure, compare, or distinguish. Quietly working in the German city of Halle, a young mathematician named Georg Cantor asked a question that no one else had dared to ask. What if some infinite sets were actually larger than other infinite sets? Using a method that is now taught in universities around the world, he proved something astonishing. The infinity of the real numbers is larger than the infinity of the integers. Two different infinities, two different sizes. To Cantor, it was simply mathematics. But to much of the scientific world, it looked like pure madness. The harshest attack did not come from a stranger. It came from his former mentor, Leopold Kronecker, one of the most influential mathematicians in Germany. Cantor had once admired him deeply. To Kronecker, mathematics should concern itself only with integers and finite objects that could be constructed explicitly. Cantor's hierarchy of infinities was, in his eyes, not a discovery, but pure fantasy. Using his considerable influence, Kronecker tried to prevent Cantor's papers from being published. He did everything he could to block Cantor from obtaining a position at a prestigious university. According to historical accounts, Kronecker even described Cantor as a corrupter of young minds and a scientific charlatan. For Cantor, this was never just an ordinary academic disagreement. It was a very real war started by someone he had once trusted. And that war would follow him for the rest of his career. The controversy did not remain confined within university walls, because Cantor's work touched upon something far older than mathematics: theology. For centuries, absolute infinity had been believed to belong to only one being: God. Cantor's theory, which proposed that infinities could exist in different sizes, was interpreted by some theologians as an intrusion into a domain reserved for the divine. But Cantor did not avoid the controversy. On the contrary, he stepped directly into it. He wrote letters to Catholic theologians explaining that his mathematical ideas did not have to contradict religious faith. Some clergy listened with genuine interest. Others argued that he had crossed a boundary no scientist should ever cross. As a result, Cantor found himself fighting on two fronts at the same time. On one side were mathematicians accusing him of fraud. On the other were theologians questioning his faith. By 1884, the years of relentless pressure had taken a devastating toll. Cantor suffered his first major mental breakdown, yet this was only the beginning. Over the following years, he was admitted to sanatoriums again and again. Throughout the rest of his life, he moved between periods of extraordinary productivity and episodes of profound depression. The most remarkable part was this. Even during his darkest psychological crises, his mind never stopped creating. During one of his stays in the hospital, he turned away from mathematics entirely and became obsessed with a completely different question. He attempted to prove that the plays attributed to William Shakespeare had actually been written by Francis Bacon. There was a tragic irony in this. A man who had once been mocked for pursuing ideas considered impossible was now chasing another theory that seemed impossible to prove. And he pursued it with the very same unshakable determination that had once driven him to explore the nature of infinity. His loneliness grew even deeper with time. The prestigious academic positions and recognition he believed he had earned were never granted to him. He spent most of his career at a lesser-known university, far from the leading academic institutions of his era. Meanwhile, much of the mathematical community continued to ignore the work to which he had devoted his life. Then the First World War broke out. As Germany struggled with famine and poverty, the aging Cantor, already burdened by declining health, could not escape those hardships. In January 1918, he died in a sanatorium in Halle. He was poor, he was largely forgotten, and he was exhausted by decades of rejection. He died without ever seeing the theory to which he had dedicated his life finally accepted. In the end, he was proven right, but he never lived to see it. Ironically, it was the very mathematical community that had once rejected him that eventually acknowledged the truth of his work. Cantor's set theory, built upon his hierarchy of infinities, became one of the cornerstones of modern mathematics. Today, his ideas form the foundation of mathematical logic, computer science, and the theory of computation. Years later, one of the most influential mathematicians of the 20th century, David Hilbert, spoke these unforgettable words about Cantor's work. "No one shall expel us from the paradise that Cantor created." Today, whenever a computer processes data or a mathematician studies infinity, they are building upon ideas that were once dismissed with suspicion. Cantor's story also reminds us of another scientist who paid a terrible price for being ahead of his time, Ludwig Boltzmann. Because he defended the reality of atoms, Boltzmann endured years of relentless criticism and died only 1 year before Albert Einstein published decisive evidence supporting the existence of atoms. Both men saw a truth that most of their contemporaries were not yet ready to accept, and both paid dearly for that insight during their lifetimes. Which leaves us with one final question. What ideas dismissed as impossible today will become undeniable truths tomorrow? Thanks for watching. See you in the next story.